Hi friends, today in this session we are going to derive an expression for amplitude and intensity of two combining waves or two interfering waves. For that, let's consider we are having a first wave that is having an equation y1 is equal to a1 sine omega t. This is our first wave, and the second wave is having a mathematical equation y2 is equal to a2 sine omega t plus phi. The two waves are of same angular velocity, but its amplitudes are a1 and a2. The second wave is ahead of the first wave by a phase angle phi. The two waves are combining. The resulting wave will have a mathematical equation y is equal to y1 plus y2. On substituting y1 and y2, we could write a1 sine omega t plus, then we have to substitute for y2, a2. Next is sine omega t plus phi. This sine omega t plus phi, I am expanding this as sine omega t cos phi plus cos omega t sine phi. I could expand this sine omega t plus phi by using a trigonometric identity like this. Then we are rewriting the expression for y as a1 sine omega t. Expand this bracket, and on rearranging I could write a2 cos phi sine omega t plus a2 sine phi cos omega t. Then y is equal to, from these two terms we could take sine omega t. Sine omega t is taken common out. The remaining thing is a1 plus a2 cos phi plus a2 sine phi cos omega t. Then we are performing a trigonometric substitution. We are substituting a1 plus a2 cos phi as a cos theta, and let's take this equation as equation number 1. Then we are substituting a2 sine phi as a sine theta. Let's take this equation as equation number 2. That is, instead of this a1 plus a2 cos phi, we have to substitute a cos theta. Then instead of this a2 sine phi, we have to substitute a sine theta. Then we could rewrite the expression for y as y is equal to sine omega t a cos theta plus, I am writing cos omega t front, then a2 sine phi is a sine theta. From this we could take a common out, then the remaining thing is sine omega t cos theta plus cos omega t sine theta. What is sine omega t cos theta plus cos omega t sine theta? Yes, a sine omega t cos theta plus cos omega t sine theta is sine omega t plus theta. Now this is the mathematical expression for the superimposing waves. Then it is clear that A is the amplitude of the combining waves. In order to get the mathematical expression for amplitude, let's analyze these two equations. We are having equation number 1 over here, and this is our equation number 2. Squaring and adding, we'll get, that is 1 square plus 2 square implies a1 plus a2 cos phi the whole square is a1 square plus 2a1 a2 cos phi plus a2 square cos square phi plus this a2 sin phi whole square is a2 square sin square phi, that is equal to a cos theta whole square is a square cos square theta, a sin theta whole square is a square sin square theta. Then on analyzing, this a1 square is retained as a1 square itself, 2a1 a2 cos phi, it's also rewritten as such. From these two terms we could take a2 square common out, and after taking a2 square common out, the remaining is cos square phi plus sin square phi, it is 1. Therefore we could write a2 square is equal to, from the terms in the RHS, we'll have a2 square cos square phi plus a2 square sin square phi, and from which a2 square is taken out, cos square theta plus sin square theta is 1, therefore a square. That means we'll get a is equal to root of a1 square plus a2 square plus 2a1 a2 cos phi. This is our expression for amplitude of the two combining waves. Then next we have to derive an expression for intensity. For deriving the expression for intensity, the connection between amplitude and intensity is directly proportional to square of amplitude. Therefore, we could write intensity is equal to a constant into amplitude square. Then we could also write I1 will be equal to Ka1 square and I2 will be equal to Ka2 square. Then multiplying this equation throughout by K, we could write Ka1 square plus 2Ka1 A2 cos phi plus Ka2 square is equal to Ka square, in which what is Ka1 square? Ka1 square is I1 plus, instead of 2Ka1 A2, 2 is 2, Ka1 A2 can be written as root of I1 I2. Then cos phi plus Ka2 square is I2 is equal to what's Ka square? Then it will be I. Then we are getting an equation for intensity as I is equal to I1 plus I2 plus 2 root of I1 I2 cos phi. Cos phi is not inside the root. This is another important expression that we have to remember. Then there is a special case in this, that is if the two intensities are same, that is if I1 is equal to I2 is equal to, let's say it's I0, then we could transform this intensities equation as I is equal to I0 plus I0, that is I am writing I0 plus I0 plus 2 root of I0 into root of I0 root of I0 square, that is I0 cos phi. I is equal to I0 plus I0 is 2I0 and this is 2I0, therefore 2I0 is taken out, 1 plus cos phi. There is a trigonometric identity, 1 plus cos phi is equal to 2 cos square phi by 2. On substituting this trigonometric identity, we will get the expression for I as I is equal to 2I0 instead of 1 plus cos phi, 2 cos square phi by 2. That is I is equal to 4I0 cos square phi by 2. This is another expression that we could use in calculation purpose. For our problematic situations and all, we will have to learn one more relation, that is we could write intensity maximum divided by intensity minimum is equal to A1 plus A2 the whole square divided by A1 minus A2 the whole square, and that is equal to R plus 1 the whole square divided by R minus 1 the whole square, where R is equal to A1 divided by A2. That is the ratio of amplitude. Or we could write R is equal to root of I1 divided by I2. Okay, remember this expression also. It's also useful in mathematical calculations and all. Hope you have understood this. Thank you.